So this is for Wednesday, March 14th, and we are going to finish up chapter 43. So we talked last time about that B cells were going to give rise to the plasma cells, and that those plasma cells then would make these antibodies. So these antibodies differ in their distribution and in their function. And so I'm just showing these to you just so you have, like, you've seen these before, but I don't know if they're really going to show up on the AP exam or not. But polyclonal, poly meaning multiple clonal, kind of makes you think of multiple clones. So this is a product from many different clones of B cells after being exposed to that microbe. Versus monoclonal are going to be prepared from a single clone of B cells traditionally done in culture. The monoclonal antibody is actually how a pregnancy test works. It has an antibody that binds to HCG, which is a hormone found with the developing fetus. So this just shows you a couple of the different antibodies that are available. You're not going to have to identify any of these, nor are you going to have to recognize them. But I did want to show them to you so you could see that the antibodies do differ. They're not all the exact same. So we talked last time about that these antibodies were going to work on the extracellular pathogens. And so I mentioned that there was all these different ways that they do it. So right now I'm going to tell you what the roles are, like how they work and how they're going to fight against these extracellular pathogens. Well, the first way is for neutralization. So what's going to happen is that the antibody will bind to that pathogen, and since it's binding to the receptors on the pathogen, that pathogen is no longer able to infect or bind to a host because now it's bound to the antibody. Another thing that can happen is optimization. This occurs when the antigens are, when the antibodies are bound to the antigens. And what that does is it sends a signal to the macrophages, which cause the antigens to be engulfed more frequently. So of course, optimization has to do with it. Now these microbes are being eaten more frequently. And then also the antibodies can work together to kind of make a complement system that basically will attack the membrane, which causes the cell to lyse, so it breaks open. And of course, if the cell is broken open, no more pathogen. So here we can kind of see that. Here would be a viral neutralization. So because of the fact that the antibodies are binding to that virus is no longer able to bind to a host cell to try to take it over. Optimization, you see that the antibodies have bound to that bacteria, and since they're bound to it, now we see that the bacteria is being engulfed by the macrophage, which of course is going to eliminate that bacteria. And the last way is by allowing these antibodies to kind of work with the complement system, which creates a pore in the membrane, and once that pore is made, then we're going to have water and various ions flowing in. If water flows into the cell will of course burst. So when we think about this adaptive immunity, there's two different ways that we can get immunized, or that we can kind of gain this immunity. Well, the first way is through active immunity. This has to do with when you're developing naturally in response to infection, okay? And so this doesn't always have to be where you've now been infected by, I don't know, the flu virus, and so now you can fight off the flu in the future. Well, we don't want to come in contact with certain pathogens, and so what they'll do is they make vaccines. And now they're really gross, but the very first vaccine was actually for smallpox. And what they did is they found someone who already had smallpox and was kind of getting better, and they weren't like super sick. They cut off one of the poxes, and then they took the pus from it and rubbed it on other people. And so they had weakened parts of the virus, and they then gave that to other people, and so their immune system was able to fight the weaker virus. Well, that's one of the ways that these vaccines work nowadays. So they'll give you a vaccination for the flu or chickenpox or whatever else they're giving you a vaccine for. And so it can either have just the antigen in it, it could have a dead virus in it, or it can have a weakened virus. And so all three of these are different ways that the vaccines are made. And so logically, if it's a weakened virus, sometimes it can get stronger, which could then cause you to get infected and kind of taken over by it. But that's actually the best way for the vaccine to work, is because of the fact that you're actively fighting this pathogen. And so by giving you this non-pathogenic form of the microbe, it allows your immune system to kind of fight and start to build that immunological memory. So if you do come in contact with it, then now you're in that second round instead of the initial round. Versus passive immunity, this usually has to do with that you have gained immunity from something else. Usually this has to do with if you are passing immunity from the mother to young, and this is traditionally done through the placenta, or it can be done through breast milk. So a lot of times, like, there's been these studies where a sick mother who pumps, she'll watch how her breast milk changes based on whether she's healthy or sick, and you'll see that the breast milk actually gets darker when she's sick because of the fact that it's chock full of all of these antibodies that she's now passing to her infant. Another way that this can be done is through injecting antibodies into a non-immune person. This is how they work with toxic bites. So let's say that you got bit by a snake, and so there's this venom in there. Well, the way that you work with anti-venom is that they inject the antibodies that bind to that venom, and so then your body doesn't respond to the venom anymore, and it kind of binds to the venom to stop it from working. And although you probably didn't realize this, but allergies are actually considered antigens. They're just called allergens. And so if your body gets kind of exaggerated or kind of is hypersensitive to different chemicals, like let's say we're talking about like pollen or a certain chemical that gets on your skin, and your body just responds like it's some type of pathogen, that is going to be considered an allergy. And so when you think about whenever you get an allergic reaction to something, let's say we'll talk about pollen, right? During pollen season, your nose gets itchy and your eyes start watering and you tend to see that your nose starts running. Well, it's because of those mast cells. Those mast cells are releasing histamines, which are causing the vasodilation, and so it's trying to flush that pollen out. And so that's why people take something called an antihistamine, because the antihistamine is going to bind to the histamine to inhibit it from working and causing it to, of course, make you have the allergy symptoms. And when we were talking earlier about the different B cells and T cells, we mentioned that we wanted to test the B cells and T cells to make sure that they weren't going to be autoimmune and that the cells would not fight against the host cell or their own cells. Well, autoimmune diseases have to do with that the immune system loses tolerance for self, and it actually turns against the own body. And so we do see this with lupus, we see this with rheumatoid arthritis, we see it with insulin-dependent diabetes, and we see it with multiple sclerosis, okay? All of these have to do with where there's a B cell or a T cell that is actually binding to their own cells and is attacking those cells. So with insulin-dependent diabetes, what's ended up happening, this is type 1 diabetes. And so the pancreas cells that make the insulin were actually attacked. And so since these cells were attacked, they cannot make insulin, which is why if you have type 1 diabetes, you have to get insulin injections because your body's unable to make insulin. So pretty cool. And then last but not least, you can get an immunodeficiency. So sometimes there are individuals that are born with immunodeficiency in which maybe they can't make, they can't go through the humoral response. So let's say that the B cells are non-functional. Well, if your B cells are non-functional, can you still have helper T cells? Well, yes, you can. And so it's still important to recognize that you still have access to the innate immunity and you still have access to your cell-mediated defenses. You just have no way to make antibodies. Same thing applies to if you don't have any like cytotoxic T cells. If you have no cytotoxic T cells, you still are able to have the humoral response and you're still able to have your innate immunity. And then also if you have an issue with your innate immunity. So there are these individuals, and the disease is called Harlequin ichthyosis. Please don't look it up. I swear it will give you nightmares. But so with these individuals, their their skin grows too fast. And so they slough off their skin too soon, and so it leaves this area for the pathogens to get in. And so now we have an issue with our innate immunity. The humoral response still works and the cell-mediated still works, but this is still going to cause them to have some type of immunodeficiency. We also see acquired immunodeficiency that can happen due to the HIV virus. So what ends up happening is HIV is going to bind to the white blood cells. And as those white blood cells continue to grow, they make more copies of the HIV virus. And once it gets to a certain level, HIV becomes something called AIDS, acquired immunodeficiency syndrome. And so these individuals have a very low immunity, and it's not usually that they die from the virus. They usually die from a cold or pneumonia or some other disease or sickness. So that wraps up chapter 43. We are done with chapter 43 now. And so you should be working on your immune system comic strip now.